In this video, we're going to demonstrate Lab 5 parallel circuits. Alright, so this is our Lab 5. What we're going to do is we're going to hook up a parallel circuit, and then we're going to record the values in a table, and then we're going to measure the values. Okay, so the first thing that we need to do is grab 3 resistors between 600 ohms and 5K. So I did that here. I got my, here are my 3 resistors. This is the equipment that we're going to need today. We need the power supply and we need our meter. 1 meter will do it. Okay. Alright, so the first thing I'm going to do is set my green meter up to measure resistance. I have the leads in the right location here, and I use the alligator clips on the end of my leads. And the first resistor that I'm measuring looks like it's exactly 1K. So then what I'm going to do is get my pen set up here. So I have 1.00 K ohms for the first resistor. The second resistor, I believe this one is a 2K. And let's see what it reads here. So we have 1.988. So for this one, we would be 1.99 K ohms. Probably could round it up to 2, but we'll use that. And then the last one I think is a 5K. So it's kind of right on the edge, but that's okay if it's a little bit over. And then so this one is 5.06 K ohms. Okay, now that I have the values of the resistors, I'm going to do the theory. So I'd have 1.00 K, 1.99 K, and 5.06 K. Now this is my circuit. We're going to hook up a parallel circuit with a 12-volt supply. So this here, this would be a 1K, this would be a 2K, and this would be a 5K. On the original lab when I made the schematic, I just used random resistors. So this is what my schematic looks like. I got 3 resistors in parallel, and then this is showing how I would connect the voltage, voltmeters and ammeters. Alright, so when we're dealing with parallel circuits, in parallel circuits, the part that is the same, I like to highlight that in green, is the voltage. So I'm going to circle the voltage here. And we have a 12-volt supply, so I can go ahead and write 12 volts, 12 volts, 12 volts, and 12 volts, because those are all the same. So my first step when I'm solving these circuits is to find the individual currents. So step 1 is to find the currents, I1, I2, and I3. So I1 is going to equal V1 over R1. So I'd have 12 divided by 1K. So when I divide those two numbers, it should be 12 milliamps. So I'll put 12 milliamps here. Next, I'll do I2, which is V2 over R2. So that's going to be 12 divided by 1.99K. So take that into my calculator, and that's 6.03 milliamps. And then my I3 is going to be V3 over R3, so that would be 12 divided by 5.0K. But 5.06K. So that one's going to be 2.37 milliamps. And then next, I can do for step 2 is I total, which equals I1 plus I2 plus I3. So I total is going to equal 12 milli plus 6.03 milli plus 2.37 milli. So I'm just going to add these three up. And when I do that, I get 20.4 milliamps. All right, and then the next one that I'm going to do for step 3 is R total, which is V total divided by I total. So that's going to equal 12 divided by 20.4 milliamps. So our total is going to be 588 ohms. All right, now I can double check that by doing the inverse of the sum of the reciprocals formula. So that's R1 to the negative 1 plus R2 to the negative 1 plus R3 to the negative 1. And so this one would look like this. It would be 1k to the negative 1 plus 1.99k to the negative 1 plus 5.06k to the negative 1, all to the negative 1. All right, so let's look at that one. Let me punch it in my calculator. And when I do that, I get 588.2 ohms. And so that checks out. Next, we'll do the powers. So we have P1 equals V1 times I1. So that's going to be 12 volts times 12 milliamps. So that's going to be 144 milliwatts. Then we'll do P2, which is V2 times I2, which is 12 times 6.03 milli. And that one's going to be 72.4 milliwatts. All right, then we'll do P3, which is V3 times I3. That's 12 times 2.37 milli. And that one is 28.4 milliwatts. And then P4 is going to, or I'm sorry, not P4. That's going to be P total, which is going to be V total times I total. So that's going to be 12 times 20.4 milli. And so P total is going to be 245 milliwatts. And then if I add up 144 plus 72 plus 28, I should get 244, pretty close. So I think I'm okay there. All right, so the next thing that we're going to do is transfer the values into this table. And so we're going to use this for our the things that we just measured for our calculated values, and then we'll look at the video to get what our measured values were. So the resistances were 1.0K, then we had 1.99K, and then we had 5.06K. And then our R total was 588 ohms. Our V total, V1, V2, V3, and V total were all 12 volts. Our currents, the first one we had was 12 milliamps and 6.03 milliamps, and then 2.37, and then the last one was 20.4. And then the powers, we did those in green. We had 144, 72.4, 28.4, and then 288, I think. Let me see if I got those right. The last one was 245. A little difficult to do those in the video. 245. Okay, so I get the calculated values from my table 1 here. All right, now for the measured values, we're going to get those from the video. However, for the resistors, we already have the measured values, so that's 1.0K, 1.99, and 5.06K. We use the measured values in our calculation, so these would all be 0% for the error. Okay, so now let's go back to the video here, and we'll put this here, and then let's watch as we make the connections. So the first thing that we're going to do is put the board together. Now on here, notice that I have the yellow and the blue highlighter. If we look at our measuring our resistance, we measured the individual resistors off the board. Then what we're going to do is plug in the board. Now if I look at the highlighter here, the yellow is going to be these connections, and the blue, this will be a little difficult, that's going to be this connection. So when I connect these across this board, all of the yellows are jumpered together, and all of the highlighted blues here and here are connected. So if you watch here, when I put these in, I'm going to put one side of each of the resistors in the yellow and one side of each of the resistors in the blue. So that's R1. Then we're going to connect R2. Okay, and then we're going to connect R3. Okay, so now all of these resistors are in parallel. The left side of the resistors are all jumpered together, and the right side of the resistors are all jumpered together. Now to make this measurement, what I'm going to do is I'm going to take my voltmeter, or my multimeter, and I'm going to change it into an ohm meter, and then I'm just going to measure the resistance from the yellow to the blue. Okay, so I got one side, I've got the meter in ohms, I have one side to the red, it's connected to the blue, and if we look here, my measured value, I get 0.589 kiloohms, so that's going to be 589 ohms. So those two aren't the same, so I'll have to do the percent error calculation. I'll do all those at the end. All right, so the next thing that we're going to do is, let's make this bigger so we can see it, is I'm going to hook up the DC power supply. So I have my DC power supply here. I'm using the red and the black lead connected to this jack. And I'm going to put the red in all of the positives. If you remember, the positives run all the way here, and the negatives run all the way here. They're jumpered together. You can see that based on this red line showing that they're all connected. So I'm going to put the red in the positive and the black in the negative. And then I'm going to jumper over the red to the yellow and the black to the blue. If you notice here, I moved them over so that they're connected. So these are my connections here. So let's go down and look at this here for the schematic. This is the connecting the voltages. So if we look here and I go back to my highlighter, I have all of these connected here in the yellow. So what I have to do is connect the red from the power supply into the yellow. That's what I'm showing here. And then the blue is all connected here, and I got to connect the black lead to the blue. And then I connect the red lead to the yellow, and then now I'm making my connection. So now I'll have 12 volts across each of these resistors. And so once we hook it up, what we're going to do is we're going to measure the total voltage, V2 and V3. Okay, and those all should be the same. Okay, so I'm zooming out here. I've got my meter. I have my meter set up in DC voltage. That's the first step. Got my black lead in the common, my other lead in the voltage, red lead in the voltage. And what I'm going to do when I'm getting ready to do this is I'm going to take some jumper wires and connect them into my alligator clips so I can probe the positive and the negative. So there's my red and my black lead. First going to hook up the power supply to 12 volts, and then we'll connect the positive lead into the red and the negative lead into the black, and it looks like I'm getting, what did that say, 11.93. So this is going to be 11.93 volts. So I'll just say 11.9 volts. All right, and that's going to be, oh, just a second. That's going to be for V total, 11.9 volts. And then what I did was I'm taking the, make this a little bigger. So I took the jumpers out, and now I'm connecting my alligator clips right across resistor R1. So I have the red lead to the left side and the black lead to the right side here. And I get, looks like 11.87 for R1. Now it's a little strange that they're not exactly perfect, but it's really close. It's probably just some measurement errors, or maybe there's a little resistance in this wire not much. Then I'll go to the next one, and I get 11.89 for R2, so we'll call that 11.9. And then for R3, I'm also getting 11.87. So we'll call that 11.9 as well. All right, next thing that we got to do is the currents, and these are a little bit tricky. So if we look at this, what we're going to do is we leave all of the resistors on the positive side connected the same way that they were, and then what we're going to do is we're going to take off one of the leads on resistor R1, and we're going to connect that through the amp meter back to the, oh, I'm sorry, this is I total. Let me back up. So for I total, what we're going to do is we're just going to disconnect this black wire, and then we're going to connect the meter through there. So let's do that first. When I switch my meter to milliamps, I got to move the plug. The red lead has to go over to milliamps. So what I'm going to do is I'm going to disconnect this wire. This wire here has the total current because this is going back to the supply. So I'm going to kick my black lead off of the supply to the black lead on the meter. That's what we're doing here. And then we're going to take the red lead and we're just going to clip it to one of these resistors. All of these resistors are in parallel. So if I clip it to any one of these pieces of metal that are touching the blue sockets, then we're ready to go. Okay, so I connect my amp meter first, then I apply the voltage. So I'm going to try to get it back to 12 volts. So I have pretty close. And so I get, looks like 19.6 milliamps for the total. So I total here is 19.6 milliamps. Okay, so now let's look at what we're going to do for I1. So for I1, what we're going to do is we're going to put this lead back in there, and we're going to disconnect one of the leads from resistor 1. So turn off the power supply, disconnect the ammeter, connect the circuit back to where I started. And now what I'm going to do is disconnect one of the leads from R1, and I'll try to zoom in here a little bit. So I'm going to disconnect one side of this resistor, and that's where I'm going to connect my ammeter. It was a little difficult for me to disconnect only one side. So I'm going to leave this side off, and I'm going to connect my ammeter. The black lead of the ammeter is going to go into 25 here, into the blue, and the red lead is going to go in there. So what I'm trying to show in the video is that we're breaking the circuit between where this lead and the blue jack is, and then we're going to connect the ammeter between those 2 points. So if they were connected, that would be how the circuit was. And then, a lot of times we say that we're kind of pretending like we're taking scissors to the circuit to break the circuit, and then we connect the leads between the 2 points that are open now. Okay, and so now what I'm going to do, I have it connected for I1, put it back at 12 volts. And it looks like I get 11.6 for I1. That would be 11.6 milliamps. I'm going to round it up to 11.6. Okay, so now when I'm getting ready to do, so I turn it off, disconnect the circuit, and now what I'm going to do is I'm going to plug that resistor back, get the circuit back to where it was, then I'm going to disconnect one side of R2, and then I'm going to connect the lead where I disconnected the resistor. So I disconnected R2 here, and then I connect my lead to where it was connected. And then I'll turn the power supply on, back to 12 volts. And for this one, it looks like I get 5.86. Okay. Then we'll go to R3. So what I'm going to do is connect R2 back exactly the way it was, back in its spot. And then I'm going to connect the negative lead off of my ammeter here to the where it was disconnected. And looks like I have it connected there. And looks like for R3, I'm getting 2.32 milliamps. Okay. All right, so I've made all of the measurements so I can turn the power off and then disconnect the circuit. So I'm done with the lab. Now I got to go through and do the calculations. So what I'm going to do here is give myself a little bit of room. And let's start off with calculated power. So what color do we want to do that in? We'll do that in, let's do that in red because we did most of everything else in red. So now I'm looking at P1. So I'm going to calculate this power here by using the measured V1 and I1. This is going to be V1 times I1. And this is all going to be the measured value. So V1, I had 11.9 times I1, which is 11.6 milli. That's how I will get my calculated power. 11.9 times, and I get 138 milliamps. Oh, I'm sorry, not milliamps, milliwatts, excuse me. Then for P2, I'll do V2 times I2. So that's going to be 11.9 times I2, which was 5.8 milli. And for that, I get 69 milliwatts. And that was 72 before. P3 is V3 times I3. So that's going to be 11.9 times I3, which is 2.32 milli. And for that one, I get 27.6 milliwatts. And then P total is V total times I total. 11.9 times I total was 19.6 milli. And for that, I get 233 milliwatts. All right, so actually, I think I'm going to erase these. I'm going to do all the percent errors in a different color. So these two are the same, so this is going to be 0%, 0%, 0%. Now for the percent error, we go down here to the bottom, it gives us it's calculated minus measured divided by calculated. So calculated minus measured divided by calculated times 100 is our percent error. All right, so let's start with the first one, which is total resistance. So we'd have 588 minus 589 divided by 588 times 100. So let me put that into my calculator. And I got to remember to take my calculator out of engineering notation for this. And I get, it looks like I get negative 0.17. So that's pretty close. The negative just means that the measured value is larger. You don't need to put the negative in if you don't want to, but because the math showed the negative, I'm going to show the negative. All right, now the next one all has the same calculation. 12 minus 11.9 divided by 12 times 100. Let's do that. And for that, I get 0.83%. 0.83% for all of these. All right. Now the next one I'll do over here. I have 12 milli minus 11.6 milli divided by 12 milli. Oops. Times 100. And for this one, I get 3.33%. This one's a little bit higher, but it's less than 5%, so we're not too worried about it. If it was more than 5%, we may have made a mistake. So here, 6.03 milli. We'll do the next one, minus 5.8 milli divided by 6.3 milli times 100. And for this one, I get 3.8%. Again, a little high, but I think it's okay. 2.37 milli minus 2.32 milli divided by 2.37 milli times 100. For this one, I get 2.1%. Or maybe 2.11%. Kind of splitting hairs. Next one, 20.4 milli minus 19.6 milli over 20.4 milli times 100. And that's 3.92%. All right, and so we got just 4 more. So 144 minus 144 milli minus 138 milli divided by 144 milli times 100. And this one is 4.17%. Next one, we had 72.4 milli minus 69 milli divided by 72.4 milli times 100. And this is 4.7%. All right, and then we have 28.4 minus 27.6 divided by 28.4 times 100. This one is 2.82%. And then the last one, 245 minus 233 divided by 245 times 100. $245 minus 233. And for this one, we get 4.9%. So that one is a little high, but still under 5%. So I think we're okay. All right, so we finished up our table with our calculated values and our measured values, and then we did all of our percent errors. All right, that's the end of this video. Thank you.